implementing these tasks, I would say, was unnecessarily long. So I decided to make some conclusion on these tasks and just bolding the technique which we can use. So in the first task, we are checking whether numbers are equals, a and b. So we are computing the distance between those two numbers, and we are comparing with some tolerance. We would set these they are equals, which the tolerance is our epsilon times absolute value of one of these numbers. And it doesn't matter which one number we will choose here on the left side, how to scale our epsilon. So this is equivalent. The next task is which number is higher. And in this task we doesn't care about equivalent. If he doesn't matter, we just pick the higher number, which is by comparison the smaller, or which just smaller or greater, right? Sorry for that. So this we can use, but we have to distinguish. Sometimes we want smaller than, but not equal. Is this comparison? I would say I want this on this side. Yeah. So a is smaller than b, but not equal. We have two solutions here. One solution is that we will put the epsilon on one this side. We can do it always, for example, on the side of a, on the left side, but then we have to decide when we want to subtract the epsilon, when we want to add the epsilon. And the way to think about this is that we have the condition that is operator smaller than, and basically our condition is happy when a is smaller than b. If we add something on this side, we are making it harder for condition to proceed, which is like preventing of not equal here. So this is how we can view it, the mind process. Or other solution for this is to expand to smaller than and equivalent. So we can make a condition like a is smaller than b, but the distance between a and b is more than the epsilon. So this means this is just negation of not equal from the task one. A is smaller than b, negate, and also in else branch, negation is higher or equal, right? So a is smaller than b, negation is a is higher or equal. Okay, this is kind of similar. A is smaller or equal to b. The solution, which we will think it, is that we have the condition, but we want now help to the condition with this. We want help on this side. So we will subtract to help the condition basically here. And the technique to expand it, here we have to be careful. We can't just, we have here or operator, or, which means it will pick the first true statement, basically. We have to firstly check for distance, so if they are equal, and is it right? We have to firstly, no, this is okay. This is okay. or equal. Yeah, we can swap these conditional. We can swap this and this. So this is okay here. So we can write like we can validate the distance, like checking for equals by computing the distance and comparison, and then like this. Yeah, so we have here two approaches. Then this is about ceiling and flooring. So whenever we have ceiling, some number which may be a bit ugly, the ceiling will found a higher closest higher integer if number is not like an integer. So ceiling of 1.1 will be 2. The problem is when it's actually 1, but some a little bit higher than 1. Then we have to subtract epsilon, and this epsilon we do not want to scale because ceiling considers steps as integers. So we don't want ever subtract some epsilon which will be like million or something, some huge number, which can easily happen in double data types, right? So we subtract in ceiling, we adding in flooring, and when we have truncate, yeah, we just have to think about that precisely, because truncate will always drop the last. It will drop the fraction part of the number. So in case it's higher than 0, in case it's positive, we actually we can have some number which is a bit smaller than 5, for example, and truncate would do 4, which we don't want to happen. And this works also oppositely when it's negative. Yeah, so this was about truncated ceiling. Next task is number is in interval, and here we want to make exclusive interval, which means that boundaries of intervals are not valid or are not considered as being in the interval. So we can do it like this. This is the technique when we have to think about it. We can also do it, we can also expand it as a greater than but not equal, and smaller than but not equal, like we did in task 3. Yeah, would change when it's inclusive interval. You can just see the animation, how it changes. So here's inclusive, here's greater or equal, here's smaller or equal, and we are changing these signs. Okay, so this was recapitulation, and now let's end up the video.